Alright gang, here we go. This is for Chem 1 Unit 10 Part 3, talking about the combined gas law. This one's super easy. One slide, okay? Now remember in the previous video we talked about the three individual gas laws. We talked about Boyle's law, Charles' law, and Gay-Lussac's law. And so we took those three gas laws, right, and we talked about individually, like how does changing, if we keep one of the three constants we're talking, or one of the three variables we're talking about, pressure, volume, and temperature, right, and we held one of them constant, what does that do if we change one of the other two to the last one? Okay, and so with the combined gas law, essentially what we're going to do is if we take all three of these and just algebraically shove them together, we end up with this new equation here called the combined gas law. So P1 V1 over T1 is equal to P2 V2 over T2. Okay, so essentially what we're saying is if we have one state where the pressure times the volume over the temperature, if we change any of those, then it'll equal this value here, pressure, volume, and temperature over temperature again for the second state. Okay. And so really we can take any of these values and then we can just solve for any of the other ones. So that's essentially what you're going to be doing here. And we're just going to do one practice problem here. And now a couple of important steps that I would do is I would, label all of the units, the numbers that you're given in a practice problem, and then make sure temperature is in Kelvin, okay, and then volume is in liters. Now your pressure can be in anything as long as it matches. Okay, but make sure your temperature is in Kelvin and your volume is in liters. All right, so those are your two keys there. All right, so let's do a practice problem. All right, the volume of a gas-filled balloon is 30 liters at 313 Kelvin, 153 kPa pressure. All right, so this would be V1, right, and this would be temperature 1. All right, because it's in Kelvin, and then so this would be pressure 1. All right, and then it says, what would the volume be at STP? Okay, so at STP, now remember this is a couple of videos ago, STP stands for standard temperature and pressure, so this means that our pressure is equal to 101.3 atmosphere, or kPa, or 1 atmosphere. We're going to use kPa here because this is in kPa, so we're going to use it because the pressure units, remember the pressure has to match. All right, and then so standard temperature and pressure, so the standard temperature is 0 degrees Celsius or 273 Kelvin. Notice that I have to pay attention to my units. Okay, that's probably the number one thing students mess up on, is not paying attention to their units on these kind of problems. All right, so it says what would the volume be? All right, so let's just go ahead and label this would be P2 and T2 because that's their second state. So the volume we're looking for is V2. So now we've got our 6 guys labeled. This is the one we're looking for, that V2. Okay, so we're solving for V2. So we're gonna do the same thing now. Remember, this is gonna be tricky at first when you start doing these. Okay, you have to really think through about your algebra, what you're doing here. Okay, and then P2 V2 over T2. Now, we are solving for V2, so that means we need to get V2 by itself. So in order to do that, we need to multiply by T2, okay? If we multiply by T2 on both sides, okay, then that means this T2 will cancel, all right, and the T2 gets moved over there. And the P2 is on top, so that means we need to divide by P2 on both sides. All right, so we'll divide by P2 over here, so the P2 and the P2 cancel. So now if we rewrote this, this would be T2 times P1 V1 over P2 T1. Okay, see what I did there? So just mushed them together, just multiplication, and then the only thing left on the right hand side would be our V2. All right there. So that's it. Okay, now we just got to make sure our temperatures are in Kelvin, our volumes are in liters, and our pressures match, and we already did that. So now we can just start plugging things in. So our V2 would be equal to our T2. Well, where's our T2? It's right here, so it would be 273. All right, times our P1, so we find P1, we already labeled as 153, times our V1, which was right here, so that'd be our 30.0, all right, and that over our P2, which is 101.3, why did I do a decimal right there? We're just going to have to bust out the eraser. Oh, 1.3. There we go. And then our T1 would be our 313. All right. Now remember, when you do this, to put this in extra parentheses in the bottom. Otherwise, you'll run into a rough time. Okay, you'll divide by 101.3 and then multiply by 313. That's no good. That's the wrong answer. All right, so 273 times 153 times 30 divided by 101.3 times 313. All right. And so I got, how many sig figs do we want here? Well, everything's in 3 sig figs. All right, so that makes life easy. So we'll be at 39.5, and the units would be liters because it's the volume. All right, so there's your answer. Now, the cool thing about the combined gas law is because it combines all the rest of them. For it combined, if you run into a case where you are applying Boyle's law, you can just use the combined gas law. And because we assumed the volume or the temperature is held constant in the Boyle's law, then we can just assume the temperature is like, 1. It doesn't matter. Just plug in 1 for that value and it'll cancel itself out. Because it's constant, it doesn't change from time 1 to time 2. So if we did that, if we did that here and we canceled out our temperatures, right? If we said, well, our temperature is constant, so these guys would be left. What would be left was just this. P1V1 equals P2V2, that's Boyle's law right there. And we can do the same thing with Charles' law. So in Charles' law, pressure is held constant, so our pressures would cancel. And so we'd be left with V1 over T1 is equal to V2 over T2. Okay. And then, so that's nice. So there's Charles' law. And then for Gay-Lussac's law, we assumed volume was held constant, right? And so our pressure was equal, or oops, Siri's thinks I'm talking to her. Okay, and so you, where was I? Oh, our volume is held constant, so our volumes would go away, so that would just be left with P1 over T1 equals P2 over T2. Isn't that nice? Okay, that's beautiful math right there. Beautiful chemistry. Anyway, so do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.